We're going to start a new unit on relations and functions. So the key thing is some definitions that we need to know. A set is any group of distinct or separate items. So just a group of items. An element, anything that's inside that set, is an element of the set. And a relation connects the elements of one set to another. There has to be a connection between one group to the other group. So what is a set? So first of all, we're going to go through and we've got a list of cities and provinces mixed around. So what we're going to do is create a set one. We're going to take all the cities and put them into a group. So we've got the cities, we're going to draw a circle around it just to show it's a set that's distinct, that's separate from the others, the provinces. So then we're going to go to the provinces and we're going to create another set. Set two is all the provinces. Put a circle around it just to distinguish it from the cities. Now, this is not yet a relation. A relation is when we have a connection between set one and set two. So we're going to start with Calgary. We're going to draw an arrow that connects it with the province that it's in. Now it's a relation. The relation is what province or state is each city in. We're going to do this for each and every city. And in the end, we now have a relation. Every item in set one is connected to a set two element. Now, if we were to add in another city, like Seattle, we get into a little problem here because Seattle does not have a province. It's in the United States, it's got a state, but it's not in a province. So this is no longer a relation. Every item in set one must have a relation to set two. Now, we could fix this. We could change this slightly to say provinces or states. We can add Washington. Now it's a relation again. So some examples, and we have different ways that we can display a relation. So the first way is an ordered pair. Notice that we have 4, 5, 3, -2, 9, 4. Now set one is always the first item in the ordered pair. Set two is a second item. So we always have a connection between the first item, first set, and the second set. And we actually have names for these. Domain is the first set in all of them. And range is the second set. And so we have connections between them. Here we have words. We have juice and orange, pop and Coke. 5 different connections between the type of drink and the actual drink it is. So another way we can show it is through the arrow diagram. Now the key thing about this is we take each set and make the list. So in this case we only have 2 items in set one, juice or pop. Now set two has 4 different items: orange, apple, Coke, and Sprite. Now what I need to do is for each item, I need to map or connect them. So juice and orange, I connect them. Pop and Coke. Pop and Sprite. Juice with apple. And the final one, pop and orange. It's already been taken by juice, but we have a second one for a pop. So we are mapping set one to set two using arrows. And a lot of times we'll put circles around each set to separate them. Another example is a table. Here we have a table of all the cities compared to the sports team inside each city. So if we wanted to make an arrow diagram, we start with set one. We've got 4 different options. And set two, and so we have to go through the list, connect each and every one. Calgary to Flames, Calgary to Stampeders. So it doesn't matter the order as long as every single connection is made through an arrow. We've got set one, set two, and all the connections between the two. So we've gone over different ways. We've done ordered pairs, arrow diagrams, and a table. Now another way we can look at something is a formula. We have no ordered pairs, we have no set one, set two, but we can choose a number and plug it in for set one. X is the first one. So if I choose 3, So I start with a chosen set 1. It calculates the set 2, and I make my ordered pair. I chose 3. The answer is 19. So I input 3. I get 19 as the answer. And I just keep doing this. I do it as many times as I want. Let's say I take -1. And so I started with -1, and I finished with -1. This becomes my ordered pair. This one over here, I'm going to choose 4 as my x, and I get my output. I get my 48. So I put it into the table of values. I chose 4, and the answer is 48. And I keep going as many times as I want. So I chose 2. I finished with 12. That becomes my ordered pair. And the final thing here is this one. Why is the following not a set? Take a look at it. Pause the video. See if you can figure out on your own why it's not a set. Why it's not a relation, sorry. And the key thing is we have set 1. We have set 2. We can assume that these numbers are connected, but there's no arrow. There's no connection. There's no ordered pairs. So this is not a relation because we don't know what goes with what. If we made it into ordered pairs, then it would be a relation.